All right, so this is the video for section 7.1, and in this section we're going to be talking about direct and inverse variation. So as you can see on this slide, anytime we have direct variation, we're going to have it in the form of y equals kx, and k is some constant. Okay, so if you look at this, notice that we could rewrite this as y over x is equal to k, and sometimes this is going to make things a little easier as we go, but we'll go over that then. Inverse variation, on the other hand, is written as y equals k over x for some constant k. And just like we did for direct variation, we could also write this as xy equals some constant, and we will use that later on as well. So basically, direct variation, as x gets bigger, your y gets bigger as well. There's direct relationship there. And on inverse variation, as your x increases, your y will decrease. All right, so just to recap what we just said. So for direct variation, we have y equals kx, and for inverse variation, we have y equals k over x. And we can write both of these. We could rewrite this as xy equals k. We can rewrite this as xy equals k. Okay, now if I look here, notice this is yx equals k here, or if you wanted to rewrite this, you could write it as y equals 5 over x. And so this right here is in the form of inverse variation. Oh, my pen's messed up. Okay, if I look at b, notice b is a linear function, and it's not in the form of direct or inverse variation, so this would be neither. That's totally a thing. It doesn't have to be one or the other. And then if I look at here, if I rewrite this a little, I can write it as y equals 2x, and that would be direct variation. All right, so anytime I'm given a table like this, or even just numbers, and I want to show if something is direct or inverse variation, I would take these formulas here, okay, and I'm going to try these out to see if there's some constant. Remember, k is our constant. A constant means it doesn't change. It's the same for everything. So if I want to check to see if it's direct variation, all I'm going to do is check to see what y over x is equal to, okay? And if it's equal to the same thing for each of these sets, then we would have direct variation. Okay, so let's look at it. So y over x is negative 12 over 2. That's negative 6. Okay, y over x, negative 6 over 4 is negative 3 halves. Clearly, those aren't the same thing. So I don't even have to check these two because I know they're not direct variation. Okay, so now that I know they're not direct, I can see if they're inversely related. So x times y equals k. So I want to check what x times y. So negative 12 times 2 is negative 24. Okay, negative 6 times 4 is negative 24. Negative 4 times 6 is negative 24, and negative 3 times 8 is negative 24. So because x times y gives us a constant, and that constant is negative 24, I can say that this is inverse variation. All right, so let's look at b now. Okay, so once again, I'm going to do the same thing. I'm going to see if it's direct variation by doing y over x. And when I do y over x, 2 over 1 is 2, 4 over 2 is 2, 8 over 3 is 8/3. Okay, right here we have a difference. So I don't even have to check this one. So we know it is not direct variation. Okay, so let's see if it's inverse variation. To do that, I check my x times y. So x times y is 2. 4 times 2 is 8. Well, 2 is not equal to 8, so I don't even have to check these. This one is neither direct variation or inverse variation. All right, real quick, go ahead and pause this video and do the monitoring progress, and then we'll go over. All right, so if you go ahead and work these three out, they shouldn't have taken you very long, and this is what you should have gotten. All right, same thing with this monitoring progress. If you want to go and look at these tables, and decide whether they're direct or indirect, go ahead and pause this and then we'll go over. All right, so this is what you should have gotten for these. All right, so let's look at example 3 now. Okay, on part A, it says the variables x and y vary inversely. Okay, so we want to stop right there. That means that y equals some constant k over x. Okay, and then it says y equals 4 and x equals 3. Okay, we want to write an equation of this. So all we're going to do is plug the y in for y, the x in for x. So we have 4 equals k over 3. Okay, now to solve for k, multiply by 3 on both sides, I get 12 equals k. All right, so to find an equation, all I want is my constant. I'm just going to plug my constant back in here. So it would be y equals 12 over x. That's going to be my equation. Okay, so now it says find y when x equals 2. So all we're going to do is plug, or x equals negative 2, is plug negative 2 in for x. So our y then would be negative 6. Okay, same thing on B, except here we're varying directly. So we're going to do the same thing, but when we're varying directly, that means y equals some constant k times x. Okay, and then it gives me a value of x and y here. So x is 4 and y is 8. So if I plug those in, so 8 equals k times 4. And to solve for k, I would multiply by 4 on each side, and I get 2 equals k. Okay, so to give the equation of this line, it would be y equals 2x. That would be my equation. And then once it says find y when x is negative 16, so that's all we're going to do is plug in negative 16 equals x. So I'd get y equals 2 times negative 16. So my y is negative 32. All right, so if I look at example 4 here, the time it takes t in hours that it takes a group of roofers to roof a house varies inversely with the number n of roofers, okay? So varies inversely, that tells me that I'm going to have something of the effect of y equals some constant k over x. Now notice here, our x is replaced with n number of roofers, so I'm just going to write k over n equals, and then the hours or time, I'm going to write t. So t equals k over n. All right, now it tells me it takes a group of 4 roofers 9 hours to roof a house. Okay, so I can use these numbers to find an equation. So if I plug 9 in for t and 4 in for n, okay, to solve for k, I'd multiply both sides by 4. I'd get 36 equals k. Okay, so my equation that I would use is y equals 36 over x, or in this case with n and t, it would be t equals 36 over n. Okay, so here's my equation. Now I'm going to use this equation to fill in this chart right here, this table. Okay, so I want to find out how much time it takes for 2 roofers, 6 roofers, 9 roofers, and 12 roofers. Okay, so all I'm going to do is plug those numbers in for n. So t equals 36 over 2. Well, that would be, my t would equal 18, so it would take 18 hours for 2 roofers. Okay, so next, it wants 6 roofers. So 36 over 6, it would take 6 hours for 6 roofers. Okay, for 9 roofers, 36 over 9, it would only take 4 hours. So 4 there. And last but not least, for 12 roofers, the time it would take is 3 hours. So 3 in here. So notice as the number of workers increases, the time it takes decreases, which is kind of the definition of being inversely related. All right, if you want a little bit of extra practice, go ahead and do these 2 monitoring progress, and then I'll give you what I get. All right, so here's what you should have gotten for these 2, which wanted you to find it when it varied inversely. All right, and this is what you should have gotten for the last couple.